Hi guys! So ngayon susimulan na natin yung ating discussion about combustion. So first, alamin muna natin kung ano ba tong combustion, and then pag-uusapan natin kung ano-ano ba tong mga usual terminologies na may encounter natin kapag nagsosolve tayo ng mga combustion problems. Alamin natin kung ano ba tong tinatawag natin complete combustion, incomplete or partial combustion, theoretical oxygen, theoretical air, supplied oxygen, supplied air, percent excess air, wet flue gas or stock gas, and the dry flue gas or the ORSAT analysis. Okay, so yan yung mga terminologies na alamin natin kung ano yung mga ibig sabihin. And then, of course, after nito, we will still be solving a problem about complete combustion. And then, sa mga succeeding videos natin, magsosolve pa tayo ng iba't ibang mga problem ng combustion. So first, ano ba tong combustion? Combustion is a unit process in which oxidation reaction takes place. But we have to be careful dito sa definition na binigay natin. Although combustion is a process in which oxidation reaction takes place, well, hindi lahat ng oxidation reaction are combustion. Marami tayong na-encounter na iba't ibang oxidation reaction. For example, yung oxidation of toluene to benzaldehyde, oxidation of hydrogen chloride to chlorine, and marami pang iba. Well, although those involves oxidation reaction, they are not combustion process. Combustion is a chemical reaction in which one of the reactant is oxygen from the air and the other is a fuel. And a fuel can be gaseous, liquid, or solid. Combustion is accompanied by evolution of light and heat, and thus, in industry, it is generally used in the generation of heat to supply energy to the process industries. So, let us try to explain that here, no? Dito sa ibaba. So, let's say we have a combustion reactor here or a furnace, no? Okay, so this is our furnace. And then, sabi sa ating definition, combustion is a chemical reaction in which one of the reactant is oxygen from the air and the other is a fuel. So, meron tayong dalawang reactant in combustion. No? Meron tayong oxygen from the air and we have a fuel. And then, ang magiging product natin dyan ay yung tinatawag nating flue gas or a stock gas. Okay, so pag-aaralan natin yan in detail later on. So for now, ito yung magiging pinaka-representation natin ng nangyayari sa combustion. So meron tayong dalawang reactant. We have air and fuel, and then nagkakaroon tayo ng product which is called a flue gas or a stock gas. Now, katulad ng ating nasabi sa definition, no, yung combustion actually, yung reactant natin is oxygen na nasa air. Kaya sinulat natin dito yung air. But, ang main component natin para sa combustion is yung oxygen content niya. Ngayon, ang oxygen na yon is being supplied by the air. And in our combustion processes, we are using 21% oxygen from the air and 79% nitrogen from the air. Okay, so yan yung component ng ating air. We know na meron tayong very small components pa na iba rito, no? But their quantity is very low and we are not considering that sa ating mga calculation. So, throughout our calculation, we will be using this percentage for our air. Yung fuel naman natin, it can be a solid fuel. So, examples ng solid fuel. It can be a coal, a wood, a paper, etc. No? Or it can be a liquid fuel. So, ano ba mga example ng liquid fuel natin? It can be an oil, kerosene, di ba? So, yun ang mga possible liquid fuel natin. And of course, it can be also a gaseous fuel. So, ano yung mga examples ng gaseous fuels natin? It can be an LPG, methane gas, or iba pa, no? So, marami tayong pwedeng maibigay na example as a gaseous fuel. Okay, so naipakita na natin ngayon yung mga sinasabi sa ating definition. No? Meron tayong dalawang reactant which is oxygen from the air and the other is a fuel which can be gaseous, liquid, or solid. Okay, now, so alam na natin that these are involved, okay, sa ating process of combustion. So ano yung tinatawag nating complete combustion? Well, the complete combustion of a fuel means that all of its combustible materials are gasified. Okay, so lahat ng combustible material natin dito sa ating fuel has been gasified or has been burned completely. So ano bang ibig sabihin nun? So we have to take note muna kung ano bang yung mga elements na or components dito sa ating fuel that are combustible. For example, carbon are combustible material, no? So we have carbon, hydrogen is a combustible material, and sulfur. These three are combustible materials. So ibig sabihin, lahat daw ng carbon na nandito sa ating fuel, lahat ng hydrogen, and lahat ng sulfur are gasified or been burned dito sa ating process. So yung tinatawag nating complete combustion. And of course, yung tinatawag nating incomplete or partial combustion means hindi lahat ng ating fuel dito sa ating reactant na fuel are being gasified or burned. Magbigay tayo ng example. Sabi natin itong carbon, hydrogen, and sulfur are combustible material, no? So, ipakita natin ano yung nangyayari dyan. So here we have complete combustion. And in here, we have incomplete combustion. So, sabi natin, carbon, hydrogen, and sulfur are all combustible material. So, para masabi natin that we have a complete combustion, itong lahat ng ating combustible material dito sa ating fuel has been gasified. So, what does it mean? That means all of our carbon has been converted to carbon dioxide. All of our hydrogen has been converted to water. And all of our sulfur is converted to SO2. So, dito sa ating fuel, if we have complete combustion, lahat ng carbon na nandito sa ating fuel has been converted to CO2. Lahat ng hydrogen ay naging water at ang lahat ng sulfur ay naging SO2. Ngayon, kapag hindi naman complete ang ating combustion or we have partial combustion, we will see here a presence of carbon monoxide. So, yung ibang carbon natin has been converted to carbon monoxide. And possible pa rin na makakita tayo dito ng H2, mga hydrogen natin na hindi na convert into water. Or possible din na makakita pa tayo ng ibang indicators na magsasabi sa atin that we have an incomplete combustion, no? Tulad ng mga soot sa ating exhaust. So, basically, if we see the CO or H2 dito sa ating flue gas or stock gas, that means we have an incomplete or partial combustion. Okay, so alam na natin kung ano yung mga possible na maging output dito sa ating flue gas, no? So, sabi natin kapag meron tayong complete combustion, we have CO2. We have H2O, we have SO2, we have CO kapag meron tayong incomplete combustion, we have H2 kapag meron tayong incomplete combustion, so hindi lahat ng hydrogen natin is na-convert sa water, and then ano pa, yung possible na naandito sa ating flue gas or stock gas. So if you're going to do material balance, makikita ninyo na yung pumapasok na air is meron ding nitrogen, no? So that means we will have here N2. Okay, dahil meron pumasok na nitrogen dito sa ating furnace mula dito sa air. So as you can see, yung oxygen lang galing sa air ang involved sa ating mga chemical reaction. So yung nitrogen natin na nandito sa ating air is not involved sa ating reaction. So therefore, inert siya dito sa ating combustion process. So yung pumasok na nitrogen, yun din ang nitrogen na lalabas sa ating furnace. Okay, so ito yung mga possible na output natin base dito sa mga naisulat natin dito sa ating diagram, right? Now, how are we converting itong mga combustible material natin into this chemical. No? For example, carbon to CO2, hydrogen to H2O, and sulfur to SO2. So we have to take note of the following chemical reaction kasi ito talaga yung gagamitin natin dito sa ating mga calculation. Okay, so sabi natin our carbon is reacting with the oxygen in the air. So we have carbon plus O2 and it is producing CO2 for complete combustion. No? So we need to balance our reaction. So we have 1 carbon, 2 oxygen, 2 oxygen. So we have a balanced reaction here. So ito na yung pinaka-reaction natin for complete combustion ng carbon. How about for hydrogen? So we have H2 plus O2 from the air is producing H2O. So since we already have 2 hydrogen here, 2 hydrogen here, so we just need a half of our O2 here in order to have 1 oxygen sa ating water. No? And then for our sulfur, we have sulfur plus O2 and this will be producing SO2. Okay, so we have 1:1 para sa ating sulfur. Now, if we have incomplete combustion for carbon monoxide, no, some of our carbon reacting with oxygen in the air is producing carbon monoxide, CO. So if you're going to balance this, makita ninyo that we just need a half of our O2 to produce carbon monoxide. Now, why this is an incomplete combustion? Because our CO can still react with oxygen to produce carbon dioxide. Kaya hindi pa siya complete. And we don't want this actually to occur as much as possible in our combustion process. Because ang purpose ng combustion natin usually is to generate heat. Katulad ng sinasabi natin dito is to generate energy. So in industry, is generally used in the generation of heat to supply energy to the process industry. No, kapag meron tayong carbon monoxide, so hindi enough yung heat na napoproduce niya or energy, no? So the goal is always to have higher conversion of our carbon to CO2. Okay, dahil mas malaki yung energy conversion natin diyan. Okay, so take note natin yung mga reaction na yan kasi gagamitin natin yan. So, ang sunod nating i-define is ano ba itong tinatawag nating theoretical oxygen. So, sabi natin itong ating mga combustible material is reacting with oxygen, producing CO2, H2O, and SO2 for complete combustion, di ba? And for incomplete combustion naman, it is reacting with O2 to produce CO. Okay? Now, ano yung tinatawag nating theoretical oxygen? Yung theoretical oxygen is the amount of oxygen na kailangan natin para magkaroon tayo ng complete combustion. So, ito yung mga equation natin sa complete combustion, di ba? C plus O2 producing CO2, H2 plus 1 half O2 producing H2O, and S plus O2 producing SO2. So, para malaman natin yung theoretical oxygen, kailangan makompute natin kung ilang moles ng O2 ang kinailangan ng ating carbon to produce CO2. How many moles ng O2 ang kinailangan natin to convert our H2 to water? And how many moles ng O2 ang kinailangan natin to convert itong ating mga sulfur to SO2? So, i-add lang natin lahat ng oxygen requirement na to. Ilang moles ng O2 dito, ilang moles ng O2 dito, and ilang moles ng O2 rito. Okay? So, theoretical oxygen is equal to the summation of the number of moles, okay, dito sa ating complete combustion and multiplied to the coefficient of O2. Okay, dahil may mga coefficient tayo dito ng O2, no? So, we just need to take kung ilang moles ng ating O2 ang nagamit natin in converting this combustible material into CO2, H2O, or SO2. Okay, so we're going to use this later on sa ating mga calculations sa mga problem. So for now, we are going to give you the definition kung ano ba yung mga yan. So, alam na natin, yung theoretical O2, yung mga amount ng oxygen na kailangan natin para lahat ng ating combustible material dito sa ating fuel will be gasified or completely burned. Okay? So, that means these chemical reactions. Okay? Para mag-take place to, gaano karami or ilang moles ng ating O2 ang nagamit from air. So, ano naman yung tinatawag nating theoretical air? Okay? Ito naman yung amount ng air na ginamit natin in order to supply yung theoretical O2 natin. So, for example, nakuha na natin yung theoretical O2 natin. So, that is just the number of moles ng O2 to produce itong ating complete combustion. So, ang theoretical air is gaano karaming air ang sinupply natin para ma-supply natin yung theoretical O2. So, kung alam na natin yung theoretical O2, imumultiply lang natin yan sa fraction ng oxygen sa ating air. We know that we have 0.21 moles of O2 in 1 mole of air. Okay? So, yung theoretical O2 natin is in moles. Now, para natin nakuha tong 0.21 moles ng O2, because in 1 mole of air, we have 0.21 moles ng O2 and we have 0.79 moles ng nitrogen. Okay, so using this, we will be able to get the number of moles ng air that we need to supply in order to produce itong kailangan nating oxygen for complete combustion. Okay, so now, alam na natin tong mga definition natin dito, no? Alam na natin yung complete combustion. Lahat ng ating fuel has been completely gasified or burned. So, yung incomplete or partial combustion, merong mga combustible material sa ating feed or sa ating fuel na hindi na-gasified or burned. Theoretical oxygen, kung gaano karaming oxygen ang kailangan natin para ma-achieve natin yung complete combustion. And theoretical air, gaano karaming air ang equivalent doong ating theoretical oxygen. So, ano naman yung tinatawag nating supply oxygen? So, yung supply oxygen, yan naman yung amount ng oxygen na finid natin sa ating furnace. So, maaaring nakuha natin yung theoretical air, pero hindi naman yan talaga yung amount ng air na sinupply natin sa ating furnace. Okay, so yung supplied air is the actual amount of air supplied sa ating furnace. Okay? So, ito, theoretical air yan. Gaano karaming air ang kailangan in order to produce itong theoretical O2 natin. But we can supply air more than the theoretical air. So, we have to take note kung gaano karaming air talaga yung sinupply natin because it's not always the exact amount ng ating theoretical air. Okay? So, ito yung actual na amount ng air that we feed sa ating furnace. Now, ano tong tinatawag nating percent excess air? So, yan yung sinasabi natin dito. That we supplied air more than the actual theoretical air. So, kung gaano karaming sobrang air ang sinupply natin compared sa theoretical air, yan yung tinatawag nating percent excess air. Okay? And how are we going to get the percent excess air? So, kailangan makuha muna natin gaano karami yung supplied air, ilang moles ng air supplied to the furnace minus the theoretical air divided by the theoretical air times 100. So, yan ang magiging formula natin in order to get the percent excess air. Okay? So, gaano karami yung actual na sinupply nating air minus the theoretical air, which is yung air needed for complete combustion, divided by the theoretical air times 100. So, yan ang ating equation in order to get the excess air. I mean, percent excess air. Now, what is the percent excess O2. So, usually kasi yun ang binibigay. Wala siya dun sa ating list, no? But, usually, we have to get the percent excess O2. Actually, the percent excess O2 is just equal to the percent excess air. How is that possible? Because itong numerator natin is supplied air minus theoretical air, di ba? So that means ang numerator natin is the excess air. Okay? So let me go back here. Let me erase this first. Okay? So supplied minus theoretical will be equal to the actual excess air, di ba? So, yan yung number of moles ng excess air divided by the theoretical air times 100. So, pareho lang yan. Ha? Supplied minus theoretical is the excess air. Now, how about for percent excess O2? So, we have excess air dito sa ating numerator. So, to convert that to O2, we have 1 mole ng air in 0.21 mole ng O2. Right? Tulad nung in-explain natin dito kanina. Okay? So, divided by the theoretical air. So, to convert that to O2, we have 1 mole of air to 0.21 mole ng O2 times 100. So, as you can see, this will be cancelled out. Okay? And 0.21 will be cancelled out. Then, ang matitira sa atin is yung moles ng O2 in excess air. And sa ating numerator and sa ating denominator, moles ng O2 ng ating theoretical air, di ba? So, that means we have moles of excess O2 over moles of theoretical O2 times 100. Okay, so pareho lang siya actually. Kasi na-cancel out naman yung 0.21 natin sa numerator and denominator. So, percent excess air is also equal to the percent excess O2. So, yan ang ating formula dyan. Mole of excess O2 over mole of theoretical O2 times 100. Okay? So, next, ano naman tong wet flue gas or stock gas? So, yung wet flue gas, alam natin, ito yung flue gas or stock gas natin, no? Yung naging product ng ating furnace. So, pag magagawa tayo ng wet flue gas analysis, so, i-add lang natin lahat ng number of moles, okay, ng lahat ng na andito sa ating flue gas. So, ilang moles ng O2, ilang moles ng H2O, ng SO2, CO, H2, N2. So, ilang moles niyan? Total moles. Okay? Okay, i-add lang natin lahat yan. And then, you will be able to get the percentage of each one by dividing yung number of moles ng ating O2 divided by NT. Okay? Times 100, so you will have the percent CO2 dito sa ating flue gas. Okay? So, ang i-consider natin lahat ng present dito sa ating flue gas. So, yan yung wet flue gas stock analysis. Anyway, magsosolve tayo ng mga problems dyan later on. So, ngayon, we are just explaining kung ano yan, ano? So, sa ating wet flue gas, we are going to consider all of this. So, wet flue gas analysis will require to consider everything. Okay. So, paano naman kapag dry flue gas or ORSAT analysis? So, all we have to do is to exclude water. So, hindi kasama yung water kapag gagawa tayo ng ORSAT analysis or dry flue gas analysis. So, ang i-add lang natin sa total number of moles is itong carbon dioxide. Okay? This one will be considered. And SO2, CO, H2, and N2. So, consider natin lahat yan. So, if we consider that, that is dry flue gas or ORSAT analysis. Okay, so aalisin lang natin yung number of waters. Okay, number of moles ng water. Yun ang i-consider natin. And then, after we got the total, we are going to get the percentage of each component. Okay, hindi kasama yung water. So, yun lang ang pinagkaiba niya. Ito wet basis, ito dry basis. Okay? Dry basis, aalisin mo lang yung water. We will not be considering that. So, okay, so basically, na-define na natin lahat ng terminologies dito. Let us try to solve a problem. Okay, so, we have pure carbon is burnt in a furnace supplying theoretical air. Assuming complete combustion, determine the composition of the combustion gases. Okay, so meron tayong furnace. Let me draw that first. Okay. So this is our furnace. And then we have pure carbon. Okay, so pure carbon to. Wala tayong ibang component, no? This is 100% carbon. So, wala tayo ditong hydrogen, wala tayong sulfur, only pure carbon. And then, we are supplying theoretical air. Okay, so theoretical air ang ating supply. So, enough air lang to produce complete combustion. And then, sabi sa ating given, we are assuming complete combustion dito. So, kailangan nating malaman is ano yung composition ng ating flue gas. Okay, yung resulting combustion gases natin. Okay, so we have our flue gas here. Okay, so first thing to do is to have a basis. Okay, so since we have a solid fuel here, so my basis will be 100 grams of carbon. Okay, so we have pure carbon here, no? So, first is to get the number of moles of carbon. Okay, so 100 grams of carbon. What's the molecular weight of carbon? 12 grams of carbon per 1 mole of carbon. Okay, so grams of carbon will be cancelled out. So we will have here 100 divided by 12. So we have 8.33 moles of carbon, diba? Okay, gram mole of carbon. Okay, so alam na natin kung ilang moles ng carbon meron tayo sa ating feed. Now, how much O2 we need in order to burn all of this carbon completely? Okay, so we need to use our formula before. Carbon plus O2 producing CO2. So this is complete combustion. So, wala na tayong masyadong kailangan pang gawin because this is 1:1. So, sabi natin, we have 8.33 gram moles ng carbon. So, 1:1, so that means for O2, we also have 8.33 gram mole. And for CO2, we have 8.33 gram mole. Okay? So, madali na, no? Itong flue gas natin, alam na natin, meron tayong CO2, which is equal to 8.33 gram mole here sa ating flue gas. Okay? Because na-produce na yan by combustion. Now, alam na natin kung gaano karaming O2 ang kailangan for complete combustion. So, our theoretical O2 is equal to 8.33 gram mole. Okay, so yan yung ginamit nating O2 for complete combustion. So, hindi naman tayo nag-supply ng pure O2, di ba? Ang supply natin is air, which is equal to the theoretical air. So, gaano karami yung theoretical air? Since alam natin yung theoretical O2, makukuha natin yung theoretical air. And this is equal to 8.33 gram mole of O2 times, so yung fraction ng O2 sa ating air, so we have 0.21 gram mole of O2 in 1 gram mole of air. Okay? So yung gram mole of O2 will be cancelled out. So we will be able to get yung theoretical air natin. So theoretical air is equal to 8.33 divided by 0.21. So 8.33 divided by 0.21. So we have 39.68 gram mole ng air. So ito yung sinupply nating air. But actually, this is not necessary dito sa ating problem, no? Pinakita ko lang sa inyo kung paano natin makukuha itong theoretical air. Because, ang kailangan lang naman natin makuha is to determine yung composition ng ating combustible gases. So, katulad ng sinabi ko kanina, ano ba yung ine-expect natin na magiging result or mga gases na lalabas dito sa ating flue gas? So, yung carbon natin will be completely burned. So, we will have CO2 here. Okay, hydrogen, wala tayong hydrogen, so we will not have water here. Diba? So, yung theoretical O2, kasi theoretical air nga yung ating sinusupply, which is having 8.33 gram mole ng O2, which is kailangan para ma-convert natin yung carbon to CO2. So, therefore, lahat ng O2 natin dito will be consumed. So, we will have 0 here. Wala tayong O2 rito sa ating flue gas. But, we know that we are supplying air, not O2. So, dapat malaman natin gaano karaming nitrogen meron dito sa ating air. Okay, so, alam natin yung ating theoretical O2 is equal to 8.33 gram mole ng O2, di ba? Ngayon, ang kailangan nating makuha is yung the number of moles ng ating N2 from air. So, paano natin makukuha yan? So, we know that our theoretical O2 is 8.33 gram mole of O2. And then, we have to multiply this sa fraction of O2 and N2 sa air. Okay? So, for every 0.21 gram mole ng O2, we have 0.79 gram mole ng N2. Okay, so saan ang galing yan? So I'm going to explain again. This is coming from the supplied air. Okay, sa ating air, meron tayong 21% O2 and we have 79% N2. So we have 0.79 gram mole ng N2 and 0.21 gram mole ng O2 for every 1 gram mole of air. Okay, so doon ang galing itong ating relationship or fractions ng N2 over O2 here. So from here, as you can see, gram mole of O2 will be cancelled out. So may iwan is yung gram mole ng N2. So gaano karaming N2 meron tayo sa air? So let's calculate that. We have 8.33 times 0.79 divided by 0.21, okay, which is equal to 31.336. Okay, so we can say 31.34 gram mole of N2. So, yung N2 natin are inert sa ating process dahil ang ginagamit lang naman natin for combustion is yung oxygen. So, therefore, lalabas to sa ating flue gas. So, we have 31.34 N2 gram mole. Okay, so yan ang composition ng ating flue gas. Now, ang pinahanap sa atin is yung composition of combustion gases. So, usually, we have to present this in percentage. Okay, so, sulat natin sa ibaba. So, our flue gas is having CO2 of 8.33 gram mole. O2, 0 dahil na-convert lahat to CO2. Nagamit lahat itong O2 natin for complete combustion. And for N2, we have 31.34 gram mole. So, ilan yung total moles natin sa ating flue gas? We have 31.34 plus 8.33, which is equal to 39.67 gram mole. Okay, so ilan yung percent CO2 and percent N2 natin dito sa ating flue gas? Kasi yan ang pinahanap sa atin actually, no? Okay, so CO2 percentage is equal to 8.33 divided by 39.67 times 100. So our CO2 is equal to 8.33 divided by 39.67 times 100. This is equal to 20.998%. So we can say this is 21%. So gaano karami naman yung N2 natin? N2 is equal to 31.34 divided by 39.67 times 100. Okay, so we know we have 29% here, so therefore our N2 is equal to 79%. Okay, so 31.34 divided by 39.67 times 100 is equal to 79%. So therefore, yan yung sagot natin. So our O2 is 21% and our N2 is 79% sa ating flue gas. Okay, so in our next video, we're going to solve the same problem, but this time we will be supplying 20% excess air. So titignan natin kapag naglagay ba tayo ng excess air dito sa ating supplied, what will be our composition dito sa ating flue gas. So with all of that and more, I will see you in our next lesson.